Hi guys, in this video I'm going to show you how you can delete in the middle of a linked list, and it's quite a bit of a long process with a lot of edge cases inside of it, so focus. I hope you don't get lost. Now there's many ways you can delete in the middle. You can delete by index or you can delete by value. Assume I want to delete, say, where I find a 2. Okay, so the process is quite simple. Okay, now assume I want to delete by 2, so I'm gonna have a parameter called d. Okay, that's I'm gonna pass in basically for the data to check if my linked list is if my data inside of that node is 2. So I'm gonna go over here into my code and I'm gonna have an integer called d for data, right? Next, let me just get you through the rough or the process, right off the bat of deleting in the middle. Assume I want to delete 2, the node v2. What I'm going to do is, of course, I'm going to have a temporary variable called t. You can call it whatever you want, and I'm going to make it loop. Alright, and I want it to stop right before when I find the 2, which is here. Alright, so that's what you want to do as step 1. Okay, stop before the node. The next thing you want to do is that create another temporary node and assign it to this which you want to delete. So I'm going to call this del. Okay, because I want to delete that. So I want to make another pointer and I'm going to assign it to the node that I want to delete. Del is equal to the node that I want to delete. Okay, after that I want to do another process, okay, which is del.next, which is this node right over here, okay, is going to be equal to t.next. Basically here I'm going to break this link right over here and I'm going to make this establish a new link till here. Alright, so that's actually no, you know what, it's gonna be like this. This does exist, but this is gonna be third node. And then of course we have the classic fourth step. Fourth step would be to delete the del node. Alright, del, this, delete it, this one right over here, and once I do that, then this thing is also going to be deleted. Okay, so that's just the multi-step process. Now I'm just going to code this out. Alright, so if I code it, it's that simple. It's a simple code, but there's a lot of edge cases because you want to handle when you have a tail. That's one case you want to handle if you're deleting at tail. The next case you want to handle is if your data is stored at, say I want to delete number 4. Now that's deleting at head, so that's also something you want to handle. Then you want to handle, let's just go into this. Firstly, you want to handle the edge case if your linked list is empty, which is a classic one, is if there's a single node inside of the list. So if you want to check if head.next is equal to null. And if that's the case, you want to delete head. After that, make head equal to null to show you that the linked list is empty whenever you want to check again. And then you want to return, of course, so that the other code doesn't get executed. That's one of the few edge cases. Step 1 was to create a temporary node and make it equal to head, right? That's step number 1. Now step number 2 is, of course, actually no, that's part of step 1. Part 2 of step 1 is to make it loop. You want to increment. So I'm just going to say t is equal to t.next. Okay, you want to keep incrementing and going to the next node. But here's the trick. The condition you want to check is different, and it's really different. Okay, you want to check for 2 conditions. One condition would be t.next should not be equal to null. I'm going to explain this why. You don't want to get to the end of the linked list. Okay, assume your t comes right over here. Okay, and you check t.next. Actually no, it comes over here, and you check t.next is null. If it is null, then you don't want to increment anymore. That's simply explained. You can understand that. Okay, this just checks if your linked list is not at, if your node is not the last node. Okay, then the next one checks if your let me just write it for you. T.next.next is not equal to the element. Okay, then you also want to exit the loop. Actually, this should have been t.data, sorry. T.next.data, meaning your t is right over here in the second last node, and you're going to the next node, which is the last node, and you're checking its data. If that data is equal to the data in your parameter right over here. Okay, if it's not equal, it means that your data doesn't exist, or yeah, your data, you have to, like, it means that you have to increment, okay, to the next node. However, if you do find the data, then you have to do some other conditions. So once we're done with that, we want to write another if statement, and that's going to be temp dot next is equal to null. Basically, you are checking which of these conditions were true or were false, and which caused the loop to exit. One of it is this one, meaning if temp.next is equal to null, alright, meaning it's the last node. So if you are at the last node and you haven't found your data that you want to delete, then simple, just return. Okay, because that would mean that your data doesn't exist in the linked list. However, the next condition, we also want to check if the loop terminated because of the second condition. So in that case, check if temp, I just want to say, write it quick, next dot data. Actually, it's not that data, it's actually that next. You want to check if you're sitting at the second last node. You can actually do that data.element as well if you want, but it means the same thing, because yeah. So if you are at the second last node and your loop terminated because of that, it means that your data is stored in the last node. Say, for example, I want to delete 5, right, and the 5 is stored in the last node. The 5 is stored in the tail. So in that case, this if statement would be executed. So once that gets executed, I want to say delete. I want to call my delete at tail function, dial at tail. Alright, so that's as simple as that. And then of course we have our classic, if none of these work, okay, these are the edge cases. If there's none of these edge cases, it's a normal program, it's a normal delete in the middle. Then you want to do that, what I told you. We already done step 1 and step 2. Now we want to make step 3. Actually no, we at step 2 right now. Step 2 would be to delete this, create a temporary node. I'm going to call it del, and I'm going to make it equal to t.next. I know it's getting a lot, it's getting a heavy, but just be with me. But t.next, I said you're going to make it equal to del. Okay, so we made a temporary node called del, and we made it equal to the node we're deleting. And then the second, the next step, the step after that would be to say that t.next is equal to del.next. After that, we're going to delete our temporary node, and that's just delete in the middle. Simple as that. You just had to watch the full video. And if you ended up here, thanks for watching.